3, 2, 1.
Stoichiometry. Stoichiometry is the study of quantitative relationships between amounts of reactants used in products formed by a chemical reaction. There are 5 steps for doing conversion. Every problem has a quantitative measurement that you start with. It also has a unit that you start the conversion with. Every problem also has a missing number and a missing unit that you want to end with. You need to plan out how many steps you're going to use in your conversion. For this, you can use a stoichiometry map to see how many steps it will take to solve the conversion. The stoichiometry map shows you how to go from mass to moles, volume to moles, and actually show you how to go to the reverse way, and actually show you the numbers that you need to use to get to each unit. The first step is to use the units to cancel from beginning to end. If the beginning unit is A, the first box needs to have an A on the bottom, because it will cancel out the A. If the unit has a denominator with B, one of the boxes will have a B on top to cancel out B, and change it to a new unit. The fifth step is to multiply all the numbers on top, divide all the numbers on the bottom. Once the boxes have been set up with the just units, put the numbers in the boxes next to the correct units. Grab a calculator and solve. Okay, I'm going to show you an example of this. So let's say that you have two A units and you want to convert it into B units. So you have two A's, and because you want to cancel out the A's, the A goes on bottom. And let's say that for every two B's there's one A. So one A here on bottom, and then there's the two B's. So the A cancels, and then 2 times 2 equals 4. So you have 4 B's.
We're going to use the equation 2C8H18 plus 225O2, which equals 16CO2 plus 18H2. And we have 5 moles of CO2, and we're trying to get 2 grams of C8H18. So first we do 2 moles over 16 moles, because that's 2 moles of C8H15 over 16 moles of CO2, because that's the mole ratio. And then we're going to multiply that with 114.28 grams of CH18 over 1 mole of CH18, because 114 grams is the molar mass. So the moles will cancel out, and eventually we'll just be left with grams, and the answer is 71.4 grams of C8H18.
For this question, we're going to be going through from volumes to moles. So we will be using 67.2 liters of H2SO4. So in order to get the conversion for this, we're going to be using 67.2 liters of H2SO4, and we're going to be multiplying it with 1 mole as the numerator and 22.4 as the denominator. Now with 22.4, we use that as a variable from multiplying anything from moles to volumes, or from volumes to moles, and the volume has to be in liters. And then going from that, multiplying it all together will be 67.2 divided by 22.4, in which will lead you to have 3 moles of H2SO4. For this question, we're going to be going from liter A over to liter B. And so we're going to be using 22.5 liters of O2, and then we're going to be dividing that by 22.4 liters. And again, 22.4 liters is the constant from any conversions including volume in liters. So once that has been divided, we're going to be having 3 moles of O2 into the bottom, and we're going to be using 4 moles of NH3 over in the top. And that will leave us with a certain number. Following which we're going to be dividing with 1 mole of NH3 and multiplying that same part with the same constant as as mentioned previously with 22.4 liters, leaving us with a total of 30.0 liters of NH.
In this problem, we're trying to convert moles A to moles B. In this occasions, the moles A are the CaC2 and moles B are the C2H2. In this problem, we have 550 moles of CaC2 that we want to convert into C2H2. To do this, we need to figure out the mole ratio between CaC2 and C2H2, and it's only 1. And because we want to convert it into C2H2, the 1 mole of C2H2 goes on top. And because we want to cancel CaC2, the mole of CaC2 goes on bottom. And this cancels, and 5.50 times 1 divided by 1 is still 5.50. But now it is moles of C2H2. In this problem, we have CaCO3 plus 2HCl, which equals CaCl2 plus H2O plus CO2. We have 0.0250 moles of HCl, and we want to convert it into moles of CO2. To do this, we need to find a mole ratio, and it's 2 and 1. And because we want to convert it into CO2, the 1 mole goes on top, and because we want to cancel the HCl, the 2 moles of HCl go on bottom. And then this cancels, and 0.0250 times 1 divided by 2 equals 0.0125 moles of CO2.
How many atoms are in 2.50 moles of zinc? To figure out when you're dealing with atoms, molecules, and formula units, you can use Avogadro's number, which is 6.02 times 10 to the 23rd. You're given 2.50 moles of zinc, so you'll put Avogadro's number on top, which is 6.02 times 10 to the 23rd atoms of zinc over 1 mole. And you would multiply the top, and that should equal 1.505 times 10 to the 24th atoms of zinc.